Welcome to Laws of Indices Level 5. Pause the video now, try the 4 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're told that y to the power of 3/4 is equal to 8, and we need to find the value of y. Now, since we have a fractional power on the left-hand side of the equation, we can use this law, which tells us that the numerator of the fraction is the power on y, and the denominator is the root. And so this means that we can rewrite y to the power of 3/4 is equal to 8 as y to the power of 3, then take the 4th root of that, and that's equal to 8. Now, to remove the 4th root from the left-hand side of the equation, we can raise both sides of the equation to a power of 4. And what this does is it leaves us with y cubed is equal to 8 to the power of 4. To now remove the cubed on the left-hand side of the equation, we can take the cube root of both sides. And this gives us y is equal to the cube root of 8 to the power of 4. Now, starting with the cube root of 8, this is 2, because 2 times 2 times 2 is 8. So our equation becomes y is equal to 2, still with a power of 4 on it. 2 to the power of 4 is 2 times 2 times 2 times 2, so that gives us our final answer, which is y is equal to 16. In problem 2, we're told that 32 to the power of n multiplied by 4 is equal to 8 to the power of 2, and we need to find the value of n. Now, in order to be able to use our laws of indices in equations like these, we need to write each of the values to a power of the same number. And here we notice that 32, 4 and 8 can all be written as powers of 2. So 32 to the power of n multiplied by 4 is equal to 8 squared, can be rewritten as 2 to the power of 5, because 2 times 2 times 2 times 2 times 2 is 32, and that still has a power of n on it, multiplied by 4, which can be written as 2 squared, is equal to 8, which can be written as 2 to the power of 3, because 2 times 2 times 2 is 8, and that still has a power of 2 on it. Now that we've rewritten all of the values to the same base, we can see on the left and the right that we're raising powers to powers. So to do this, we use this law, which tells us that to simplify, we multiply the powers together. So starting on the left-hand side, we can multiply together 5 and n, and this gives us 2 to the power of 5n. This is multiplied by 2 squared, and it's equal to 2 to the power of 3 times 2, and 3 times 2 is 6. Now, looking at the left-hand side of the equation, we're multiplying indices together, and to do this we can use this law, which says that we need to add their powers when we multiply. So 2 to the power of 5n multiplied by 2 to the power of 2 becomes 2 to the power of 5n plus 2. And this is equal to 2 to the power of 6. Now that we have the same base on both sides of the equation and they're equal to each other, we can say that their powers must also be equal to each other. And this means that 5n plus 2 must be equal to 6. We can start solving this equation by subtracting 2 from both sides, which gives us 5n is equal to 6 minus 2, which is 4. And finally, by dividing both sides of the equation by 5, which gives us our final answer, which is n is equal to 4 over 5, or 4/5. In problem 3, we're told that 9 to the power of q is equal to 1 over 27, and we need to find the value of q. Now once again, we'd like to use our laws of indices to solve this problem, but we can't do that until we rewrite each side of the equation as powers of the same number. And here we notice that 9 and 27 can both be written as powers of 3. So we can rewrite 9 to the power of q is equal to 1 over 27 as 3 to the power of 2, because 3 times 3 is 9, raised to the power of q is equal to 1 over, and 27 is 3 to the power of 3, because 3 times 3 times 3 is 27. Looking at the left-hand side, we can see that we're raising powers to powers, and so we can use this law, which tells us that to simplify expressions like those on the left-hand side, we can multiply the powers together. Since 2 times q is 2q, the left-hand side of our equation becomes 3 to the power of 2q. Now the right-hand side of the equation can be rewritten using this law, and the law tells us that 1 over 3 to the power of 3 can be rewritten as 3 to the power of minus 3. Now we have the same base on both sides of the equation, we can say that their powers must be equal to each other. And this means that 2q must be equal to minus 3. To find our final answer for this problem and to solve the equation, we divide both sides by 2. And this gives us q is equal to minus 3 over 2. In problem 4, we're told that 100 to the power of a multiplied by 1000 to the power of b is equal to 10 to the power of w, and we need to find an expression for w in terms of a and b. Once again, we need to write each value in this equation to a power of the same number in order to be able to use our laws of indices, and we quickly notice that 100, 1000 and 10 can all be written as powers of 10. So 100 to the power of a multiplied by 1000 to the power of b is equal to 10 to the power of w can be rewritten as 10 to the power of 2, because 100 is 10 times 10, raised to the power of a, multiplied by 10 to the power of 3, because 10 times 10 times 10 is 1000, still with the power of b on it, is equal to 10 to the power of w. Now, since on the left-hand side of the equation we're raising powers to powers, we're going to use this law, which tells us that to simplify, we multiply the powers together. So starting with 2 times a, we have 10 to the power of 2a, multiplied by 3 times b becomes 3b, so we have 10 to the power of 3b is equal to 10 to the power of w. Now looking at the left-hand side of the equation, we're multiplying together indices which now have the same base, so we can use this law, which tells us that we need to add their powers together. So 10 to the power of 2a multiplied by 10 to the power of 3b becomes 10 to the power of 2a plus 3b. And that's still equal to 10 to the power of w. Now that we have the same base on both sides of the equation, we can say that the powers must be equal to each other. And so we can say that 2a plus 3b is equal to w. And looking at what we have on this final line, we have an expression for w in terms of a and b. So this is our final answer to problem 4.